And then once you're done weighing it, just put it back there. In case there's a problem, you can always go and check it. So while we're waiting for it to start, if you want to do that calculation real quick, you don't have to. It's due Friday, so you have plenty of time to do number 3 and number 4. But the filter paper plus the magnesium hydroxide minus the filter paper gives you your grams. That's your experimental. And remember, yesterday we calculated the theoretical to be 0.87. So then you just plug it into your system error equation, and then you are ready to rock and roll. Yep. Just put it back on the table because even though you're done with it, in case there's something wrong, we can always go back and do that. Sometimes it's like, oh shoot, we counted. Oh shoot, and so.
So would number 3 just be what we got for MPO?
So you just weighed the filter paper and the magnesium hydroxide, right?
Oh, it's this way.
And then you got to subtract off the weight of the filter paper.
Oh, I don't know why it meant. I thought it meant like.
Oh, we have to make sure that I. Okay, we got to make sure that we stop at the office hour time, which is 10:45, because no, not 10:45, 11:55, because then we've got to do something for advisory. We didn't do it yesterday because we were in the middle of the lab, so today we got to have our advisory. All right. Let's get back to morning, everybody. We will be at 10:45. We're going to start advisory, not 10:45. At 11:55, we will start advisory. Okay, we didn't do the advisory yesterday because we wanted to finish the lab on time. So do not log out at 11:55 because we all have to do some advisory. And the students in the class are going to make sure I stop at 11:55. Okay. Now, who was I videotaping? Yes, I was okay. So, Dominic, Keen, and Ray, and Leo. What was, I'm going to send you the mass of the magnesium hydroxide plus filter paper. Oh, hate autocorrect. What was the weight? Yep, the thing you just weighed today. 3.536 grams. So I sent it to everyone, but the only people that need it are Ray, Keen, Nick, and Leo. Okay, so that's what you need then to solve for number 3 and number 4. The rest of you all got your stuff either in class or in the Google Sheet that I sent you. Okay, so if you can't find if you need help with the lab, let me know, all right? Because no one came to office hours this morning. You guys can email me or come to office hours. So if you need help with the lab, let me know, but it's due on Friday morning. Okay, so I'm giving you a couple days to do it. Don't wait till Thursday night and then be like, oh crap, now how do I do it? Now it's 11 o'clock at night and Mr. Strauss is asleep. What am I going to do? So don't wait till Thursday night. All right. Plus, you're going to get a little bit of homework on probably Thursday. I don't think you'll get homework tonight, but you'll get some homework on Thursday. Okay. Any questions at home?
No.
Anybody else? Questions at home? All right, then today we're going to go through the test. So I emailed you your test. I graded it in Notability, and you received an email. How you doing, Leo? Ask Mike for your weight. Actually, it's Andrew. Ask Andrew for the weight of your magnesium hydroxide and filter paper. Okay. So you might want to get that email out so you can see what I marked wrong. So we're going to go through the test.
Yeah.
I'm not muted. I am not muted. All right. Can you guys hear me at home okay?
Yeah.
Yeah.
All right. So like I said, you might want to look for that email that I sent you where you've got where I showed you what you got wrong. So for number one, first thing we're gonna, oh, I gotta share this. All righty. All right, here we go. So we're calculating the wavelength of light released when an electron falls from the fourth to the second. So my change in energy is equal to the final minus the initial. So the final level is the second minus the initial, which is the fourth. Now, when you subtract a negative, you end up with a positive. So my change in energy is negative 245.6 kilojoules per mole. It's important to have that unit on there, Neil. Well, that's the energy. That's not the, put your cell phone away, you don't need it. That's not the wavelength. To find the wavelength, we're gonna use that equation. Yeah, that's better. So we have to do a little bit of algebra. So we solve for wavelength, Aiden. Now, what about Planck's constant? I know my energy is 246.6. Actually, I think it's 245. Yep. If my energy, Aiden, is in kilojoules per mole, then my Planck's constant must be in kilojoules per mole. Then multiply by the speed of light. Put that in my calculator. And I get 4.87 times 10 to the negative 7th meters. So if you didn't put the meters, you lost a half a point, okay? Now the directions say to use sig figs. I didn't take off points for significant figures, but I did write down what the correct number of sig figs should have been. So in this problem, I have 3 there, 3 there, and 4 there. So my final answer should have 3 significant figures, okay? So I didn't take off for it, Lucy, but I did like write down the sheet, say, oh, you had too many sig figs. Now, what type of light is this? So we go to our so I don't know if you can see this well or not, but that's 10 to the negative 6th. That's 10 to the negative 8th. So that means the visible spectrum is 10 to the negative 7. Okay. So 486, that's 400 right there. So 486 would be somewhere right about there. Okay. All I was looking for was visible light. If you put blue or green, that's fine. But I was just looking to see that you put because I said the type of light, so it'd be visible light. Now, I did make sure that your answer was consistent with what you put in part A. So for example, if you did the math wrong in part A and you got 10 to the negative 28th, that would put you over here in gamma rays. So I just made sure that your part A and your part B were consistent with one another. So that's why you may have written something else for part B and still got it right, because it was consistent with what you put in part A. And I should mention, if I made a mistake on your test, just let me know and I'll fix it, okay? When you grade a million tests, you're bound to eventually make a mistake, Ryan. I know people think I'm perfect, but I'm not. All right, how much energy is produced by 1 mole of gamma rays with a frequency of 3.2 times 10 to the 15th seconds? So I'm looking for energy. I've got a frequency. And there's only one equation, Gavin, that relates the two. Now it says that I got a mole of them. So if I have a mole, Dominic, I'm going to use the Planck's constant that's a mole. And multiply it by my frequency.
Mr. Strauss,
Yep.
how do you get a second to the negative first power? Like, what does that entail?
So if you go back in our notes, frequency is the number of waves per second. Okay.
Okay.
Gotta go back and erase it. Number of waves per second. I wish they would write the waves on top, because then it makes a little bit more sense. Think of frequency. I'm gonna maybe get in trouble for saying this. You can kind of think of frequency a little bit. No, I'm not gonna say that. It's similar to a speed, meters per second, right? A speed or miles per hour, that's telling you a distance per time.
Okay.
So a frequency is saying you've got waves per time, but they don't write the word waves. They never write the word waves on the top. Now your seconds are in your denominator. So when something is in the denominator, it's to the negative first.
Okay.
So that's and yes, it is like confusing, because it's like, well, what the heck is an inverse second? I know what seconds are, but what's an inverse second? It just means it's in the denominator.
So seconds to the negative first is just per second.
Exactly.
Got it.
So then I multiply those two together. Now, I highly suggest you write down the correct answer, so that if you want to take the retake, you are prepared. Now, the retake is not the identical test, but it is of equal difficulty. I got 3 sig figs there, Sam, and 2 sig figs there. You round to the least number of sig figs. So that's 2. I'm going to round to 2 sig figs. My answer is 1,300 kilojoules per mole. Okay. Number 5. So one thing I'm trying to teach you guys is not just chemistry, but a process of solving. Leo. Got it. Thanks. So, like if I asked you to calculate the potential energy of a mass, and I told you that the mass of it was 15 kilograms, and the height of it was 4 meters off the ground, so even if you don't know anything about what I'm talking about, and you shouldn't, because this is physics next year. If you write down your info, it helps you narrow down the correct equation. So even if you don't, and like I said, I wouldn't expect you to understand what I just said. You got a mass, you got a height. What's the right equation to use? That one, right? So it's not just about getting the right answer. It's about learning how to do a process of solving a problem so that you can attack any problem and solve it. That's why I make it worth 1 point writing down the info. So I've got a wavelength. Wavelength, LE must be in meters. So there are 1,000 millimeters in the meter. That was worth 1 point. What am I trying to find? Frequency. So I'm looking for an equation that has wavelength and frequency in it. So when I go down here, there's only one equation that has wavelength and frequency in it, and it's that one. When you look at all those equations there, Andrew, there's only one that's got wavelength and frequency. So even if, again, you're not quite sure what the problem's doing, there's all these other words there, Sophie, that are trying to confuse you. Stick to the numbers. Write down what you know. It'll help you figure out the correct equation to use. Now you need to know that the head has to be in meters. Solve for frequency. Divide by my wavelength. And then my frequency will be I got 3 sig figs, 3 sig figs, 4 sig figs. So my answer should have 3 sig figs. So that's my frequency. Now, Jacob, I want this in megahertz. A mega is a million of anything. So I take my 104,000 hertzes, because a hertz is the same thing as an inverse second. 1 times 10 to the 6 hertz is 1 megahertz. 104 megahertz is the answer. So if you go to your radio and you dial in 104 megahertz, that is the radio station Z104. So they're telling you the frequency to tune in at. So if you're listening to 105.5 triple M, that's the frequency of the waves, okay? And sometimes you may even hear them say that. 105.55 triple M broadcasting at 105.5 megahertz, okay? And if you want to look for alien life, you can go out into Arizona and they have these big radio stations and they're just scanning the sky, scanning all the radio waves from 88.7 WERN to all the way up to the high end 106.1. So they're scanning and looking for extraterrestrial life. Any questions on number 3? All right, number 4, we're looking at the momentum of a neutron. I even put it in bold. So the mass of a neutron is 1.67 times 10 to the negative 24. You have to convert to kilograms. If you got to the negative 28th, you're probably not using your calculator right. Okay. Never use the caret. The velocity is 1.88 times 10 to the 7th. The equation for momentum is P is equal to mv. And that's what we get for 4A. What is the wavelength? Well, you can use either of these equations. mv is P. So you could just use the answer from part A. So my wavelength, now this is for a single neutron, so we're using the Planck's constant for one object, divided by my momentum, and wavelength is always in meters. Number 5, trying to find the energy. We've got a mass. Mass must always be in kilograms. You writing this down, Leo? Joey, you writing this down? You guys write down the correct answers, whether it's on a piece of paper or in Notability. All you guys at home too. All right, you want to have something to study off of. There's my equation. 0.7 kilograms times the speed of light. Some people just forgot to square it. They wrote it squared in the equation, but then they forgot to square it in their calculator. If we get 6 times 10 to the 6.3 times 10 to the 16 joules. Your answer is energy is always in joules. RP. So the world uses 7 times 10 to the 12th watts of energy per day. No, not per day. The world uses 7 times 10 to the 12 watts. So I've got this much energy. Now, a watt is the number of joules you use per second. So if I've got 7 times 10 to the 12 watts, it means that I'm using this many joules every second. So every second that goes by, I'm using this much energy. So I have to divide by my wattage because I'm using that many joules every second. Now, what does the problem ask for? Hours. So there are 60 seconds in a minute and 60 minutes in an hour. So it comes out to be 2.5 hours. So that number, 7 times 10 to the 12th, was from about 20 years ago. So 20 years ago, there were 5 billion people on the planet. Now we've got 7 billion. And we'll have another 2 billion in the next 20, 25 years. So 4 more United States. Every man, woman, and child in the United States. 4 of them. So we're gonna have to find a way to get more energy. And we've actually been doing a pretty good job of both finding energy and making our machines more energy efficient. So actually the energy consumption of the United States is actually slightly decreased because of energy saving devices. So what questions do you have on number 5A or B? Number 6, a lot of words here. In a particle accelerator, the one like at Fermi Labs in Chicago, if you want to take a field trip there once COVID is over, it's a cool place to go. It accelerates subatomic particles close to the speed of light. In one experiment, they crash electrons into positrons. Each electron is being accelerated to a velocity of 2.5 times 10 to the 8th meters per second. The uncertainty in momentum is 0.5. Calculate the uncertainty in position. So there are 2 equations that have delta x in it. This one and this one. Just giving some wait time.
Mr. Strauss, can
Yep.
you let my phone into the meeting because I have to switch from my iPad?
Sure. What just happened? Ah, wrong place. So which of these 2 equations, this one or this one, do we have the information for? Do we know the mass? We could look it up, right? Do we know delta V? No. We know V, but V is not delta V. But we do know delta P. So the correct equation is the one on the right. So I'm going to do my algebra. Delta X is going to be greater than or equal to H over, okay? This is for one electron. And since it's for one electron, Jordan, it's going to be 6.626. Divided by my delta P, which is 0.5 times 10 to the 8th. Times 4 times pi. I'll put that in my calculator. And I actually have only one significant figure there. So I'm going to round to 1 sig fig. If you put it into your calculator correctly, your uncertainty in position is 1 times 10 to the negative 42nd. So that, I think, the two problems that got people the most were number 6 and number 7. And when you see the answer to number 7, I'm glad you guys are at home because you can't throw things at me. I'm worried about the people in class here, so you're not gonna throw anything, are you, Manly? All right, for number 7, a pulsar is a collapsed star that emits radio waves at regular intervals. The output of the star is 10,000 million volts. The frequency of the wave is 72.10 to the 6th. What is the speed of the wave? So what type of light is this? It's a radio wave, right? What is the speed of all types of light? So the answer is 3 times 10 to the 8th. I just want to make sure you guys understand that the speed of light is 3 times 10 to the 8th for all types of light. So all that other information was not important. Okay. So I will give you until next week, Tuesday, to take the retake. Okay. You have 60 minutes to do it. Okay. Part of the reason that is first of all, you don't need 60 minutes to take the test. Second of all, is if you're trying to cheat, having a time limit, it slows you down. Cheating slows you down. So you're going to run out of time. So you need to know what you're doing. So that's another reason why. But honestly, I've given this test a million times. Most people take about 35 minutes to get it done. So it shouldn't take you that long. And you get the grade on the second, you get the grade on the retake. So it's not the average, it's not the higher one, it's whatever you get on the retake, that's your grade, okay? And then I just want to emphasize the importance of doing your labs. Labs are weighted the same as tests. So your your lab, that's open note, open book. You can ask your friends for help. You can ask me for help. So getting your labs in is really important because that's like a open book test that you can ask for help on. So don't forget to turn your lab in, okay? You're not going to get any homework tonight, so you might as well just get your lab done tonight, get it over and done with and submit it. Any questions at home before we transition to new material? Yep, it's the ones right around the corner, remember? All right, if there's not any questions, then we are going to go back to our quantum mechanics. So we left off on page 14. It's up to you if you want to take it on a piece of paper or a notability. So just a quick recap while you're finding your notes. The first model of the atom was the billiard ball model. The atoms were solid balls. Then came the Thomson model, where the atom was plum pudding and the electrons were inside of it. Then came the Rutherford model, where he discovered the nucleus. Then came the Bohr model, where he said the electrons orbit around the nucleus at certain distances. And that's kind of the model that you left off with in middle school. It's not wrong per se, but it leaves out a lot. The correct model of the atom is the electron cloud model. Now, the reason why we save that for high school is because it's a mathematical model and we need your math to catch up. And in all honesty, until you know calculus, it's pretty hard to do the math. Well, actually, it's impossible to do the math. So I'm going to describe it to you, but we don't do any math with the last model because it's way too difficult. You have to be in college to do it. So I'm going to give you an analogy. And so I'm just going to review some of the math you've already learned with you. In math class, the sine function looks like this. Goes from 0 to 1. It crosses the x-axis at pi and 2 pi. You remember this from math? Sine and cosine. And one of the major reasons why you study sine and cosine in math is because it describes the movement of a wave, right? You've been talking about waves. Sine and cosine describe waves. Now, what happens when you square a number? Makes it bigger, right? But it also makes it positive. So when you square something, it makes all negative values positive. So if I take this graph, actually, let's write the math. If I square that, if I square sine x, what does it do to my graph? Makes everything positive, okay? Now, like I said, we're not going to be doing math. All I want you to take away is what happens when you square a graph? Makes it positive. Okay, so that's all I want you to remember. You don't have to worry about the sine and the cosine. When you square a graph, it makes it positive. That's all I want you to remember. We're going to skip this part. The other thing I want to review with you is the difference between the value of an answer and how many answers or how many solutions. So if y equals x and y is 4, how many solutions are there for x? Anybody in the class want to take a crack at that one? How many solutions are there for x, Ryan?
4.
The value of x is 4, but
But
how many solutions?
1.
One solution. So all I just wanted to review with you is the difference between the answer and the number of solutions. So there's one solution, and it just so happens that x is 4. How about for our next example there? Y equals x squared. If y is 4, now how many answers are there? X could be 2 or -2. So we have 2 solutions now. And this is why we don't teach you the correct model of the atom, is because we are going to assign a probability to the answers. What is the probability the answer is 2? And what is the probability the answer is -2? 50%. In the quantum mechanical model, we assign a probability. We calculate a probability of the outcome of what's going to happen. Okay? So there is a 1 in a million chance that Scarlett Johansson's going to fall in love with me and marry me. But there's a chance. 1 in a million probability. So there's a percentage to an outcome. Is it a likely outcome? No. Could it happen? Yeah, but not very likely. So in quantum mechanics, we're going to assign probabilities to outcomes, okay? And we're going to stop there, and we're going to then do our advisory, okay? So I'm going to switch over to the computer so I can show you what you're doing for advisory. You're still going to need your iPad because we're going to go into Zello, my fellow. So do not log out. Okay, Jacob? I'm going to share my screen. And I'm just going to read you the directions. As soon as I get that out of the way. And get rid of that. All right, so it says here on February 23rd, that's yesterday, every student will have a task to complete in Zello. Also, teachers of 11th graders should hand out the ACT non-test instructions for them. Okay, so I've got something for a couple of you. Please ensure to take a picture of this information on their phone or iPad in case they lose their paper. All right. So, and then on Thursday, 11th graders. So if you're an 11th grader, we will do this on the 25th. So if you log into Zello, there should be a task for you to complete. Actually, I should have some of you share your screen. So Zello. Now your screen is going to look different than mine. Let's see if they have a task in here for you. There might be something there under assignments. So when you log in, is there something under assignments for you?
No, there's not.
Let me take a look here. They said there's. Let me just, I'm gonna steal your, just 1 second. Hold on. I'll steal your iPad, Sam.
That's fine. And
Okay, I got it. All right, everybody at home, I know what to do here. Sorry. So I'm going to show you, if you go, I'm just going to show you, stay in Zello, all right? Stay in Zello. Because each grade is going to do something else. That's the wrong course. There we go, February. So, all right, if you are in 10th grade, you're going to do career and lifestyle costs. If you're in 9th grade, exploring career factors. And if you're in 11th grade, career demands. So let's see. I'll play the video here.
Advisory for today, Tuesday. It's also going to be the same lesson for this Thursday. So if you are a 9th, 10th, or 12th grader, you are in the right place. 11th graders, you should be working on getting ready for the ACT, doing some paperwork. So what I want to walk you guys through with is Zello Lesson 1, which is your assignment for today. So you will be logging on to Zello. I know for 9th and 10th graders, you've been doing that a lot for scheduling. For 12th graders, I'll remind you how to do that. Before you can complete Zello Lesson 1, chances are there's going to be a prerequisite. You're going to have to save 3 careers also in Zello before you start Lesson 1. Once you start the lesson, it'll take you about 15 to 25 minutes. And because we have 2 advisory periods for that, you should have plenty of time, get as much done today as possible. So let me show you how to log on to Zello, mostly for my 12th graders who might not have done it this year. You're going to go to Links for Students from the website, and then you're going to go down to Zello halfway down, and then you'll log on with Google.
Okay, hold on 1 second. I gotta get this to, I gotta get into Zoom real quick for my iPad so that you guys can see it here. Okay. Oops. Son of a biscuit.
About 15 to 25 minutes. And because we have two advisory periods for that, you should have plenty of time, get as much done today as possible. So let me show you how to log on to Zello, mostly for my 12th graders who might not have done it this year. You're going to go to links for students from the website, and then you're going to go down to Zello halfway down, and then you'll log on with Google. Once you log into Zello, it's going to look like this. I'm logged in right now as a 10th grade student. To get to the lessons, you're going to scroll down. It'll be on the left-hand side, and the lessons will all be in order here. The first one right under the colorful box is going to be Zello Lesson 1. That's what you'll focus on for today. Some of you guys probably remember Zello from last year. You will have different lessons this year because you're 1 year older. You're a different place in high school. And so if you've done Zello Lesson 1 last year, it will be a different lesson today. So for 10th graders, it's going to be career and lifestyle costs. So when you click into it, I've already completed my career search, but chances are what you'll see down here is you must select 3 careers before you can move on. So let me show you where you do that. So you'll just be able to click on the careers right down here. Mine's already done, but I'll just go over to careers. Once you click into that button that says before you can unlock this lesson, click on careers, it's going to take you here. And here's a place where you can select 3 careers you're interested in. It's kind of nice because you can set up some sort of parameters. So you can set a minimum salary. So say I want $60,000, okay? And then you can set the amount of education. So if I just set high school, you can see there's 160 careers. If I also include college, 444, okay? So I would set it for whatever level of, like whatever you think you're gonna do after high school, or as a way to narrow it down. Once you've narrowed it down, they're all in alphabetical order, and you can scroll through and pick one. So for instance, I might want to do aircraft mechanic. Maybe that's something I'm interested in thinking about. So when I click into it, it'll have the salary range, the general amount of education required, and then it gives me all this information, job description. There's interviews with people who've actually done it. It shows that there's an increasing demand for this career. So once I get out of school, it'll be easier to get a job. It'll tell me the core tasks, what you'll do on a daily basis, what the workplace is like. So all this sort of stuff, workplace conditions, it's just a really rich resource. And that's what we want out of Zello. It's, you know, we're using it for scheduling right now, but we also want you to be able to get informed about careers. And we also want you to be able to examine, you know, what am I interested in? And how does that relate to some kind of personalized path that I'm going to chart through high school so that I can really make the most of my life afterwards, whatever that looks like. So if I like this career, what I can do is I can save it and it'll be saved. And then I can say, how do I feel about this career? You know, maybe I like it a lot. Maybe I'm not sure it's a good fit. Maybe I think it's a possibility. So I'll say it's a possibility. And I've got 1 career saved, okay? So I've got to get 3 of them saved. So now I can go back, explore another career. Maybe I want to do addiction counselor, and I can learn about that, and I save that. And once I've got 3 careers saved, and I would take a decent amount of time looking through these just so that you can pick the ones that you really like. I'll go back up to the left in Zello. That'll take me back to my home page. And then I can click in and I can get started with the lesson. And once I do that, I click get started and I can work my way through it. And once, if I ever want to press done, I can press done, and however far along, it'll save it. So I can come back to do it later, okay? That's basically it. So I hope this video was helpful. What you guys are gonna do, like I said, is log on to Zello, do that first lesson right here, and chances are you'll have to pick the careers first. Have a great day, and we'll see you guys all for the next advisory.
So you guys are going to be doing lesson 1, which is the career planning. So you
Advisory for today. So if you've done.
So make sure you go under career and lifestyles and complete 3 different careers. Okay, if you're in 11th grade, I've got something else for you to do. Okay, so maybe you want to do it during lunch or some other time. So like I said, tonight, get your lab done, and then you can fill some of that stuff out in Zello. Okay, I'll stay on the line in case you guys have questions. So then you guys. So this is what you can do. Take a picture of this. Sam, did you take a picture of the instruction sheet so you don't lose it?
No.
Take a picture of the instruction sheet. If you're going home for lunch, see you later.
I'll see you next week. Thank you.
See you later. I'll never do this another time, but especially this year. Oh, I gotta get that. Oh, Shiza. It's downstairs. At least I think it is. Yep. All right. See you in a little bit.